Welcome to Chapter 10 of my CCENT study material. This is dealing with the application layer. So in this chapter, we're looking at things like our applications, like www and email, DNS, DHCP, things like FTP, some basic protocols that are used in an atypical network. So this chapter is broken down into application layer protocols, well-known application layer protocols, and the message heard around the world, and we're going to end with a summary. So the application layer protocols, these are going to be application protocols dealing at layers 7, 6, and 5 of the OSI model, or the application layer within the TCP IP model. So if we're dealing with the application layer specifically, that's going to be things like DNS, HTTP, SMTP, POP, DHCP, FTP, and instant messaging. Those are all at the application layer. At the presentation layer of the OSI model, we're talking about things like coding and conversion of application layer data, the data compression, data presentation, encryption. That is both encrypting and decrypting information. At the session layer, that's going to be creating the functions that will maintain the dialogue or the connection stream between our source and destination, depending on the application. It will also handle the exchange of information to begin the dialogue, as well as keeping them alive, if need be, restarting and termination. So, things at the presentation layer, that could be things like QuickTime or MPEG or GIFs or JPEGs. These are going to be the different types of extensions. So, in general, the TCP/IP application layer, things like DNS or Domain Name Service Protocol, that's going to help convert domain names to IPs and IPs to domain names. Telnet, it's a terminal emulation, very similar to like PuTTY. This is all clear text though. So if you're looking for a secured version of Telnet, it could be a SSH. Bootstrap protocol, it's a precursor to DHCP. DHCP, Dynamic Host Control Protocol. That's how we can auto-assign IP addresses or lease addresses out. Then we have HTTP and HTTPS, Hypertext Transfer Protocol. Essentially, that's how we get websites from a web server to a web client. FTP and Trivial FTP, that's how we transfer files. If we're looking at sending and receiving mail, it's going to be SMTP, and that's used for the transfer of mail messages. And if we're talking about receiving or retrieval, it will be either POP or IMAP. POP being Post Office Protocol, IMAP being Internet Message Access Protocol. So SMTP, POP, and IMAP, that's normally dealing with how we get our email. So let's talk about some of the different types of networks. We have a peer-to-peer, which is non-centralized. Every peer has its own resources that they share. And if you want a resource from a peer, you request it directly from that peer. There is no centralization there. Next, we have a client-server architecture dealing with peer-to-peer. And again, that could be something like an instant messenger, where they're both the client and the receiver. We have common peer-to-peer applications like BitTorrent, eDonkey, eMule. Bitcoin, I wouldn't really classify that as a peer-to-peer application. That's more of a digital currency, but it's there. Again, getting away from our peer-to-peer without centralization, we go to a client-server model, and that's where it is more structured. It is more centralized. Everything resides on the server, and the server then pushes it out. And then individual clients can then upload files back to the server, but that server is where everything is centralized. Moving on to well-known application layer protocols and services. So these are going to be ones that you need to know for your exam. things like HTTP, it's used to browse the web. HTTPS is also used to browse the web, but more securely. We have things like SMTP and POP for email. So example, with our HTTP or HTTPS, if we want to break it up, we can. And I'm going to see if I can do a highlight. So here's our URL. Here's going to be our protocol. Here's going to be the domain name. And here's going to be a specific file that it's going to be requesting. It will use that protocol to access that domain. It will access that file. Again, to develop a publish and retrieve HTML type page, we're going to be using HTTP. If we are looking at other ways to get messages, we could be looking at things like get, post, and put. Get is a client request. Post and put are used to send the message as well as upload data to a web server. Those aren't as common when we talk about HTTP and HTTPS. Normally, we care more about HTTP is what gets the appropriate file. In reality, get is what's going to be requesting the data, but we don't normally get that nitty-gritty. Another big one that I've noticed on a lot of the exams are SMTP and POP. So you will use SMTP to send mail. I cannot highlight at an angle very well. And you will use POP to get mail. So if you want to block people the ability to send email, you'd be blocking SMTP. If you want to block people from receiving email, you do it via POP. So another big thing is, how does it go from one person to a recipient? Well, through DNS, it will get shipped to the right location. Using the appropriate SMTP address, it will go to a mail server. The mail server will transfer it to the recipient's mail server, and then the recipient's mail server should allow it to go back. Again, SMTP is for transferring mail, assuming that it's formatted correctly, assuming it's using the appropriate port. A common port for SMTP is port 25. That's not the only port, but that's one of the common ones. So that's going to be used to send email. To receive email, it's going to be POP or IMAP. If we're using POP, it's going to be port 110. That's very important because they ask you several port questions. Another common one that they do is this whole mail user agent versus mail transfer agent versus mail delivery agent. So you send an email, you are the mail user agent. That will be sent to a mail transfer agent. Now, the mail transfer agents may send it back and forth to other transfer agents until it gets to a mail delivery agent. That's going to be the recipient's email domain. And the delivery agent will actually deliver it back to a mail user agent. These are important because I've noticed on the exam, they have asked me a few times, you're sending an email from a mail user agent, what is the next hop, or what is the next device called? Mail user agent, mail transfer agent, mail receiving agent, mail delivery agent. So you kind of have to know what they're titled for. And mail delivery agent accepts a piece of email from the mail transfer agent for delivery. That's the big thing. The mail transfer agent gets it. The mail delivery agent delivers it. Again, SMTP is used to send mail. transfer it reliably and efficiently. If we're looking at how do we receive email, it's going to be either POP or IMAP. Let's talk about DNS for a second. We want to go to google.com or cisco.com. Well, we don't know the IP address, so DNS has to be queried for us to figure out what the IP address is to go to the appropriate location. So if you type google.com in a web browser, it should take google.com, translate it to an IP address, and in reality, we're going to that IP address. Here we're using cisco.com instead of Google, but same principle. Type cisco.com in a client. Before it even gets to the internet, it has to query a DNS server. DNS will go, hey, cisco.com is really this IP address. Once your computer knows the IP address, it can then be routed accordingly. We do not know, or we don't normally remember IP addresses. We normally remember domain names or names. That's why we have DNS. That way our client can request it, cisco.com. DNS will respond with the appropriate IP address, and our client will know, okay, to get from me to where I need to go, it's going to be that IP address. That way the client will then know, okay, to access that web resource, I can go to that website. Are there different types of DNS record types? Sure there are. Normally there is a record type A, and that's just an IP address, or a quad A, which is really an IPv6 address. We have an NS, which is a authoritative name server. We have a CNAME, or an alias name, or a common name. We have an MX, which is a mail exchange. And those are just a few of the common types of DNS records. If you're looking at how to route email, you're normally dealing with MX records. That's mail exchange. If you want to give a web server and you have just its IP address, but you want to point DNS names to it, you're normally going to be doing a record. DNS does have a hierarchy. Things like a .com, .gov, .info, .biz, .jp, .au, .co, .us, so forth and so forth. Alternatively, you can also then look up DNS type names through a command line symbolet or command line command at a Windows command prompt. If you type ns lookup, you should be able to resolve the appropriate names and IP addresses for a few different types of resources. Like if you type in, let's go ahead and do that. NS lookup. I'm using Cox's DNS. What is Google's IP address? Google IP address currently is 216.58.217.206. What about www.google.com? I notice it's a different IP address. So that's what NS lookup does. It allows us to look up IP addresses and or domain names. Other nice little commands could be things like DHCP. And that's, again, dynamically assigning IP addresses. So we have a DHCP server that will lease addresses for a set amount of time. So here we have a pretty similar larger network where an ISP might be leasing IP addresses to home clients, could be leasing IP addresses to corporate clients, to wireless clients, or to other ISPs. All right, so how does DHCP work? It works in a very simple way. When a new client comes online, it will send a DHCP discovery broadcast to its network. The DHCP server will send a unicast DHCP offer. The DHCP client will broadcast a DHCP request, and then the DHCP server will respond with a DHCP acknowledgement. That that two actual pairs handshaking will actually then allow the client to be leased an address. Another common one is FTP. That's being able to transfer files between clients. The client will connect to the server, and then the server will then send the data that it needs. SMB, or server message block, that's normally how we map resources. SMB is normally a client server or request response protocol, so the servers can make their resources available to clients on the network as they require. Things like browsing shares to copy files. All right, so let's talk about things heard around the world. So we're going to be looking at the same general concept, but more globally. So the Internet of Everything, or the Internet of Things, and that's where everything is connected with one another. So we have application, transport, internet, network access. That's our TCP model, TCP model. And we actually, as we go down, we will divide the layers with the application streams into segments and add the appropriate headers. The transport layer will then pass the segment into the internet layer. It will then get packaged into a packet or into a IP datagram before it leaves the network access. And that will be, they'll put a MAC address on it and send it out the wire. Getting the data to the right place is normally based off of the appropriate port number. Like if you are sending email, if you're using SMTP, that normally means we're using port 25. If we're looking at FTP, that's port 20 and 21. If you're using HTTP, that's port 80, or HTTPS is port 443. So that's the big thing, is you have to know the appropriate port numbers so that you understand where the data is flowing to and from. And that's actually it for this chapter. I want to thank you.